Hold on 1 second. I'll be starting in just a second. I need a drink. Alright, welcome to an extremely casual episode of Cooking with Unity. I just was doing this mostly because what I was thinking about working on is kind of fun, and I just wanted to see if anyone else was interested in this, to play around with this type of stuff. And we haven't done data manipulation too much on the show. And I just figured that it might be better to do this in front of a camera rather than just play around with it on my lonesome. So I was looking at some star data. There's a few catalogs that you can get really detailed astronomical data for stars. Why is this set to the wrong mode? Hopefully I'm coming through. Okay, why is it set to surround? That was weird. Hopefully my audio is still going through. Does it look like it? Yeah. Probably doesn't sound too much different between the two, but it wasn't even set to it. It just for some reason changed to it. That was weird. All right, so there's these star catalogs you can get at, and I don't actually know what the licensing information is for them. I couldn't find it anywhere. The HYG database is in GitHub, but I couldn't find the actual information on like attribution or use of this stuff. So I'm not sure if any of what I'm going to be showing up here can be used in a commercial context, and even in a personal context, I'm not entirely sure how this stuff will work. There's a few different options that we had here. The HYG database is gigantic. It is just huge, and it has more stars than I want to actually parse through. Habcat is a really good archive, except for it's just stars that are habitable, which is cool, but it doesn't necessarily mean it'll look like the night sky when we're done with it. And HabHYG is kind of a merging of that data of the first two, and it's how big is it? It's big, but this is the one I'm probably going to use just because it has a lot of useful information already built into it. Yeah, it's got 45,000 stars in it. And this is the one I've decided to use for today's episode. You could pull data from any of them. Some of them have different types of data to work with. The main reason I like this one is it has a display name here. And what these are is if the thing has a proper name, it will use the proper name. And if the star does not have a proper name, it uses a proper identifier for that star, which I think is neat. So we could theoretically like raycast out and show information about each star if we wanted to. So that's the main reason I've chosen this one. That and the dataset is smaller than the huge HYG dataset. The only thing that's missing from this dataset, in my opinion, is it has the absolute magnitude, which is so these values X, Y, and Z and absolute magnitude are super useful for just throwing things into say Unity and seeing how they look, because you can basically use the absolute magnitude to change the scale of whatever's representing the star, and you can use the XYZ components, and then the scale will also change over distance, so you theoretically should be able to get an approximation of the night sky if you use this data together. But I'm probably not going to be able to display all 45,000 stars at the same time. And so what's actually more important than absolute magnitude in this perspective is relative magnitude. We want to actually know what it looks like from Earth when looking out on these stars, because there are things that are super, super bright, but they're so far away they're less bright than other stars that are much closer and dimmer. So we're going to need to calculate that one ourselves. And anything else that's really interesting here? Some of the star, actually most of the star catalogs don't have the XYZ information. If you want to get this, it's very easy. If you have the distance or even just the parallax and the ascension, declination type stuff, you'll be able to calculate that out. You basically just rotate into that space and then project out based on the distance. So let's get started here. I'm going to go ahead and go into Unity, and we're going to create a new project. And I'm going to put this under the Cooking with Unity super repo, actually. So we're going to put this under GitHub super repo, and I'm going to call this star data. And we're going to create the project. And so here we are. We're in a scary blank space. And I'm just going to see what we got here. So we've got the one I'm going to be using here is habhyg here, .csv. If I just drag this in, does it know that it's a text asset? It might. But I'm not, it doesn't say it up here though, so I'm not sure. Hold on, if I click here, what does it take me to? Text asset. It does know that it's a text asset. Excellent. So, so we can use this as an asset and then read data out of it. And so we're going to create a script to read some data out of this thing. So I'm going to call this star data parser, and this is going to require develop boots up here. What this is going to require is we're going to need a public text asset data source, and that's all we need. And then in start, we're going to put all this data somewhere. Go through all the data and put it somewhere. So, so what are we going to need? We're going to need a star data structure of some kind to store this stuff, this information in. I'm going to create a class for this. Actually, we're going to call this star data. Actually, let's make it a mono behavior. Let's make it a separate file. So, save. We're going to create a new script. We're going to call this star data, and this will contain an individual star's data. So, what we care about storing for right now, we could store all this information. Actually, maybe it would be best to just store it. Let's see what we got. Nah, let's just store what we care about. So we're going to want the name. So we're going to have a public string name. Put that lowercase. What else are we going to do? So we're going to have the name. We're going to have the XYZ, the absolute magnitude, and then I also want to calculate the relative magnitude. So the XYZ information, though, we're going to store that on our transform for this. So I'm not going to even store that separate in the star data here. We're just going to have that inherent to the transform. So all we care about is public float absolute magnitude and public float relative magnitude. And what else? And because we're going to need the distance for the absolute magnitude, we might as well store that too. So the public float distance. Public float distance. Now, relative magnitude can be calculated from the absolute magnitude. So we could turn this into a property that self-calculates. And I'm going to go ahead and do that. Why not? We can always change it back later if it's a problem. So what we're going to do is I need to figure out, calculate relative magnitude from absolute magnitude and distance. All right, let's see what this says. So this gives us the distance. Let's see if there's something that already has done the trouble for us. Apparent magnitude. Alright, so given the absolute magnitude m for objects in our galaxy, you can also calculate the apparent magnitude m for any distance d in parsecs. And I think we're already in parsecs, so that's useful. X, Y, Z, and G in parsecs, and distance from the sun in parsecs. Perfect, we're already in the right term. So here's our equation. Ooh, it has a logarithm in it. Sweet. So this is the apparent magnitude calculation. So let's convert this. I'm just going to paste this in here and see how this pastes. It's not going to look great. Oh, it actually looked better than I thought it was going to. I'm just putting this for my own reference real quick. So So what we're going to do is public float relative magnitude, and we're going to set a get method and we're not going to have a get set method. This is going to be just calculated based on our other data. So hopefully I'm using the right, hold on, get set C#. Yes, even I look these things up. Accessors, I didn't even know what they were called. I did know what they were called, but alright, so I did everything right except for we don't need this semicolon here. So what we're going to do is relative magnitude get, and what we're going to return is return, and then this equation. So absolute magnitude, so that's the big M here, minus 5 times 1 plus mathf dot log 10 of what? Let's see what the actual statement looked like here. Alright, so log 10p, what's the p is the, oh wait, this is parallax. We actually wanted the distance. So 1 minus log 10d. So 1 minus log 10 of distance. No, just distance. And we need one more. So in theory, this should give us our absolute magnitude. And let's go ahead and be a little bit smart about this. Let's cache it too. Let's create a private float. I'm going to call it underscore rel magnitude equals 0.0f. Actually, let's make it -1, because I don't think it's possible for a magnitude to be, yeah, by definition of magnitude should never be above, should never be below a value. I'm just using this to know that we haven't set it yet. So what we're going to do is if, and this shouldn't have a tilde, this should be an underscore rel magnitude. If rel magnitude does not equal, or if relative magnitude is less than 0.0f, I'm going to do less than or equal to just in case, because it really shouldn't be anything that has a magnitude of 0 because we wouldn't be able to see it. Rel magnitude less than or equal to 0.0f, then we're going to store rel magnitude, so rel magnitude equals this chunk. This will just save us if we have to call this multiple times, because it shouldn't change for a star, right? We might, if we were moving around in the universe later, it might matter, but for right now we're just going to do this. And then we will just return this rel magnitude, so we don't have to do the math again. And then else, we just return rel magnitude. We don't need to calculate it at all. And this needs to be absolute magnitude, not rel magnitude. And we're not going to do anything in the start or update things just yet. But I want this to be a model behavior so that we can attach this to an object that has the transform to it, so that we can use the transform for the XYZ information. So we're going to save this. And what we're going to do is, so start a parser. Do I want to do it this way? Yeah, let's do it this way. What we're going to do next is public game object star prefab. Let's just quickly make this star prefab here. So we're going to do, what is it called? Create, we'll just create like an empty object. We're going to call this a star. I'm going to create a new material. And actually, I don't want to create this as a star. I want to create a, let's do a, should we do it as a quad or a sprite? Let's do it as a quad. We're going to call this star. And we're going to change our material here to be called star. And all we're going to do is give it a texture of default particle, and we're going to use transparent diffuse. So now if we throw this on our star, we should see at some angle that something that kind of looks like a dot. There we go. So we're done. This is going to be our star prefab. And cool. So now what we're going to do is I'm going to put star data on the star. And we're going to start populating stars here. So during start, we're going to... how do I want to do this? So first of all, I want to see if there's some sorting operations we can do. C# sort by member. How to sort a list of objects by a specific member. Okay, we could use link, but we don't have access to link. Oh, there we go. So this is the magic. So we don't want to modify the actual list, but that's cool. All right, so we're gonna have a list of stars eventually. So let's make that star list first. Okay, I guess I am going to have to do this separately. I'm going to create this, call this star data mono behavior. And then we're going to create a separate one called star data, which I think I'm just going to put in this file, which is valid. Public class star data. I'm putting it outside the class declaration. Usually whenever I define two things in a class, I usually put them underneath each other. This one I want to have access separately, and it's probably... We could break this into a separate file later if we wanted to, but this will be fine. And I'm just going to basically give it all of these properties. And then instead of in star data mono behavior, what we're going to have is we're just going to have a public star data data. As it says casual, I'm kind of making this up as I go along. So now we can put these into a class that's not a mono behavior as we parse it, and then we can have a list of these things. So what we're going to ultimately end up with is a public list. Oh yeah, we're going to need to define that, aren't we? System.collections.generic. And I have decided I'm going to put this in a separate file. Ultimately decided. Creates... Okay, I'm going to rename this to star data mono behavior. Create C# script star data. Quit this thing now. And this one is not going to be a mono behavior. And we're just going to put all this cool stuff in it. And we don't need the class definition again. Bloop. Alright, save. So, we're going to do public list star data equal star list equals new list star data. Save. And so we're going to start and we're going to parse this stuff. So I'm going to create a separate function for it. Void parse data. And then we're just going to call this at start parse data. And so here we go. So we've got our text asset data source, and we're going to be parsing it. So C# parse CSV. Let's just see what we got here. All right. File helpers. What do these do? That's not what we want. CSV helper. Is this a separate thing? That's actually kind of nice. Microsoft Public License. Reading and writing CSV files. I'm going to reinvent the wheel. There we go. Yeah, there's the reinvent the wheel method. Because I think that it's useful to know kind of how parsing stuff works. So this is going to use a stream reader. We're not going to use that. We're just going to use our text asset. So parse data. So I'm going to create just a temporary string text full text equals data source dot text. And then what we're going to do is, so let's split this into lines. So the way we can do that is we can use, good, split. String array text lines equals full text dot split. And we use the separator of a new line. And then what else we're going to do? So now we've got our thing set into lines. And so now for each string line in text lines. So these are comma-separated values, I think. Let's just double-check. I mean, that's what CSV stands for, but it doesn't technically have to be commas, even though it's called a CSV. Let's just open this in a text file real quick to make sure. Open with text edit. Hopefully text edit won't crash. Perfect, it did not. So, yeah, there we go. So it's comma-separated values. That's all it is. So we're going to grab... so we're going to do... we're going to create, so for each of these lines, with the exception of the first, we actually don't want the first line. How do I avoid the first line? Let's just do a bool. Bool first line parsed equals false. If first line parsed, then we do our full parsing. Else, we just do nothing, but we set first line parsed equals true. So, in all other cases, if we've parsed through and skipped the first line, we're going to separate this out by, we're going to do something similar to this, except for it's going to be called values equals full text equals line dot split, and we're going to split it on a comma. And then we're going to actually read in this data into a new star data. So star data star equals new star data. And actually we need to put this there. And then star dot, and now we have all of our little things we can fill in. So star dot name equals, so we want to just count this over. So we're doing numbers here. Here we are. So this is column 0, 1, 2, 3, display name. Here we go. So 3 is the one we want. So this equals values 3. Star dot distance equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Values 12. Star dot absolute magnitude equals what does it equal? Absolute magnitude equals, so this is, distance was 12, right? Yeah. So 12, 13, 14, 15, 16. 16. Value 16. All right. And so now, and then after we're done with all that, we want to actually add our star to our list. So we're going to do star list, and this doesn't need to be here. Star list dot add star. So once we're done, we should have a huge list of stars that have this data in it. And I guess what we could do is we could debug.log that stuff once we're done parsing it. Let's do it. All right, so let's do a quick data check. Data check. This is going to be horribly slow, but let's find out what it does. For each star data star in star list, debug.log star.name. We'll just do that and see what we get. So we'll see if this works. We might have a bug. If we have a bug in this thing, it's probably going to cause some problems. Add star. Why couldn't we add a star? Star list, unexpected symbol. Public list, star list dot add. Oh, I didn't put a semicolon here. Save. So we may crash quickly, we may hang, it might totally work but look like it's not working. Params care has some invalid. So wait, what's invalid about this? Oh, no, I have to use the smaller quotes. Hopefully this will still work. And probably same here. Does that fix it? Too many characters in character literal. Alright, that's what I thought. New line character literal. This is not it. Oh, I have the wrong slash. There we go. Let's try that. Cannot implicitly convert from string to float. Okay, that's fine. We just do dot to float. Wait, no. Float dot parse. Bam. Save. And we still have the same problem here. Oh, but now we don't actually have... So in Stardata, remember we said that we'd use the transform for the XYZ, so we actually should probably store that here too. So let's go ahead and do that real quick. So first of all, let's do the same magic here. And then let's also add the position data real quick. So public vector 3 position in parsecs. I'll just call it position. Save. And so we will do position dot, sorry, star dot position dot x equals, I'm not sure if this is valid, but we'll find out. Start dot position dot x, actually let's just do start dot position equals new vector 3, and then we just use the XYZs, so those are in what columns? So one after distance, so 13, 14, and 15. So we just do 13, 14, and 15. So float.parse values 13, comma, 14 and 15. Save. All right, are we compiling yet? We're compiled. All right, amazing. So what we're going to do now is I'm just going to create an empty, we're going to call this star manager. Star manager. We're going to put our star data parser on it. We're going to drag in our data source. I'm going to save the scene. We're going to call this test1. I'm going to save the project. I'm going to check it in to version control real quick. Source tree. Super repo. Here it is. And we just go grab all this stuff. Add it in. Initial check-in for star parsing so that if something goes real bad, we won't lose anything. So that should go pretty quickly. Honestly, the largest file there is the CSV file, ironically. So I'm just going to let that go. While that's going, I'm going to just quickly see if anyone's commented or if anyone cares about what we're doing. I can hear you. This is great. They should teach in school that programming is 90% looking things up. I absolutely agree. And the thing is, this is true of any level of programmer. You are always learning when you are a programmer, always. And yeah, that's the one thing that people don't understand coming fresh out of college when they finally get a job. And it took me years, even when I had a job at Sony to realize this, because I was just around these programmers that were just doing amazing stuff. And I started hanging out with my friend James for a while, and he you know, I was like, how did you figure this out? He's like, well, what I did is I searched Google for X, and then that helped me in this way. And then I searched Google for Y, and then I searched Google for Z, and that was a dead end. But then that came back to Y and mixed it with X, and there we go. We got something cool. And the only thing that would have been different if I'd asked him the same question 10 years earlier would be he would be going to the library instead of the internet. That's it. So yeah, looking things up is important. That's why I try to show it on my show. When I don't remember something, I just look it up. Not a big deal. So Unity, star data. So here we go. Are we ready to try this? Are we going to do this? I'm doing it. I'm going to hit play, and we're going to wait. Wow, it was index out of range. Okay, so we broke very quickly. How quickly did we break, though? So index out of range 3. Weird. On what line did we mess this up? Must have been early. So let's check it. I'm just going to do a debug.log. And I'm just going to create a line number. So int line number equals 0. Debug.log line number. And we're going to, at the end here, do line number ++. Save. Hit play. Let's see how far we get. Oh, now we're going to crash. It probably crashed trying to debug log like a billion things at once. Because evidently it got way farther than I thought it did. Or I did something really stupid here. I don't think I did anything particularly stupid. This is actually what I expected to happen the first time. I'm kind of surprised that it got an index out of range exception. It was just perfectly happy with itself before. Alright, so let's look at our file here while this is going. And I want to look at the text version of it, so I'm just going to go in here. We're going to open this up with text edit. So I'm curious if maybe at the end of this thing Is there a new line at the end? There is. So I think it's happening at the very last line. So actually, it parsed considerably faster than I thought it was going to. Computers are magic. That being said, I think this has died pretty badly, so I'm just going to quit this. Unity, Stardata. Alright, so I'm going to go back into our Stardata parser. We're going to get rid of this debug.log here. And what we'll do is, let's just catch the exception. Let's just do it. So, try. Let's put the try around all the places that this could actually happen. So, try. This is the first time that we've shown exceptions on the show, mostly because I actually don't believe in exceptions. Catch, and what was the one that we got? Out of range exception. Here, let's see. Index out of range exception C#. So if we did a try, do they have a try catch example? Catch. Naturally not. Alright, but I think all we have to do is just say, I think it's just catch index out of range exception. And all we're going to do is just break. Actually, let's continue. Save. So now if we hit play, oh, index out of range exception, system exception. Let's just do system.index out of range exception. Save. Does that fix it? Yay. Alright, so if we hit play now. Yeah, it's probably still going to do this. Alright, let's quit this. Go back in again. I'm going to get rid of our debug log at the end. That's just how we were going to check to see if the data got in there. I actually... So if we make the... Well, it is public list, star list. Why does it not show up here? Can you not use lists as... Oh, Stardata is not... Here, let's do system.serializable. Now does it show up in the list? That might do it. Yes, star list. Okay, so now I can just view it here. So I'm going to get rid of our debug.log data check here. And I'm going to get rid of the line number because we're not using it. And I'm going to get rid of the line number here. Save. Let's try this again. Alright, so it went. If I go to star list, ooh, good sign. Awesome. I'm really shocked that the Unity did not crash when I did that. Look at the scroll bar. Just scrolling is... Oh, this is agony. I can't even get it to scroll right now. Oh, there you go. It scrolled a little bit. But they're here. Do they have what looks... It looks like they have the right names, certainly. I have no idea what I just clicked on. We'll find out. It's still scrolling from before. Sweet. Alright, well, we're like 16 clicks behind. I'm just going to hit this and see when it decides to stop. Actually, I better click it harder and longer. Oh, it actually opened one up. See? There it goes. Oh, and then we're done. It was there for a moment, I swear. Hopefully we got that on video. So let's see. Alright. So... you worked at Sony. What did I do there? I worked as a tester on Siphon Filter Omega Strain, Siphon Filter Dark Mirror, I did tools testing and stuff on Logan Shadow, which is another Siphon Filter game. And I started doing production work on the PSP Resistance game, and did a lot of work on a lot of scripting work on Uncharted Golden Abyss for Vita. Worked there for 8 years and was laid off. It sucked. But I really enjoyed my time there, and it was great. It was Sony Bend Studios specifically, and had a lot of fun there. But yeah, started as a tester, and probably shouldn't have. Probably should have started as a programmer. Should have asserted myself more. I didn't have a whole lot of faith in my programming skills when I started, and so I decided to just get my foot in the door as a tester, and it was a lot of fun. I actually liked testing quite a bit. It's both not as easy as people think it is, and it's also a lot easier than people say it is, if that makes any sense. The big thing that sucks about being a tester is typically you work really long hours and no one cares about your life or anything, which is fine. But because working those long hours, it's tough, but it's not the same as working the long hours as, say, a designer or a programmer, where you are actually expected to produce more than just a sheet of paper that says what's broken, and instead have to fix what's broken at 4 a.m. That's a much harder job. But yeah. Was that my first job in the industry? Technically, no. My first job in the industry was a startup company by the name of Cubic Sky Interactive that I started with my roommates in college when I was up at DigiPen. So that was my technically first industry job. When I was 14, I also did web development stuff back in the dot bomb era. But that's technically not the same industry. It is still, there's some programming aspects in there, but it was not as programming heavy as it is now for web development. And back then it was all HTML, which is just a markup language. So we got the star data, and it looks like it's getting in there. And it looks like the data is somewhat valid. So that's cool. So what we're going to do now is I want to prune the star data a bit. So what we're going to do is, let's go ahead and check these in. It works, I think. So, star catalog. So, I didn't explain this very well. As I said, this is casual, so I didn't really have to, but I'm going to go ahead and say it anyway. So, there's things called exceptions. Anytime that you see null reference exception or et cetera, exception, these are things, most of the time that you deal with them, they're system-level exceptions. You can actually throw your own exceptions and make your own exceptions as well. I'm not going to show that here. But you can catch any exception too. And the way you do it is you do a try statement around whatever you're doing. So in this case, we're grabbing values that may not exist. Like if you go outside, say you have a list that's 10 long, and you say values 30, that will be out of range. That'll cause an index out of range exception. And so what we're doing here is, if we get an index out of range exception, we're just saying, hey, it's cool, just keep doing your thing, man. Don't worry about it. Just do it. We haven't added the start of the list at this point, so you're safe at this point. Like, we did create a new star data, but it will ultimately just destroy itself in the garbage collector, because as soon as we come out of this for each loop, actually, as soon as we come out of this particular loop, it will no longer exist. So this is just saying, if you have trouble parsing the line, just go to the next line. I think it's only actually happening on the very last line, so we could have done a break here, which would do effectively the same thing in this scenario. But I did a continue just in case there was some line in the middle that was mucked up for some reason, like had too few commas for some reason. So, what were we doing next? So I wanted to go through some of this. So let's go back to what I was looking at here, which was, there we go. So we can sort the list in place. So what we want to do is, after we got the list, we're going to sort star list by relative magnitude. So what we're going to do is, the list name is star list dot sort. And I'm just going to copy basically this whole thing here, and we'll figure out how it actually applies to ours. So xy x dot last name dot compare to. So what we want to compare is we want x dot relative magnitude dot compare to y dot relative magnitude. So this should sort our list by magnitude. And is this ascending or descending? I think this is actually the opposite order that we want. So I'm going to actually switch this to x and y. The reason is we want this to be sorted so that the highest relative magnitude is there. And so what I'm going to do to just check this is we're just going to do a quick debug log. Debug.log, what is it called? Starlist dot starlist 0 dot magnitude, relative magnitude. Save. So this should be a large value rather than a small value effectively. So if we hit play, there we go. You can see that the list is definitely in a different order. 21.00095. That sounds pretty good. Let's just double check it. I'm going to just reverse these again. Y and X. Save. So now we should hopefully get a number that's smaller than 21.0095. Negative infinity. Ooh. Negative infinity is not a fun one. So evidently somewhere we got a problem with the equation here. Negative infinity sounds like a divide by zero type problem. We're using logarithms. I'm going to admit to you right now that I understand logarithms. I know when they're useful, but they're still one of my flakiest subjects when it comes to mathematics. So what are the distances looking like? Are there any that are just really, really short distances in this list? I'm just going to go to our numbers thing. We're just going to sort by the absolute magnitude. Oh, wait, the distance is what we want. So distance is 0. Oh, negative infinity. That's probably Sol. We don't even really want Sol on the list. So I'm going to actually do star list 1 and see what we get here. Okay, we got something. It's a negative value. I wasn't expecting that, but so it's possible to have a negative value for the relative magnitude? I guess it is. Which means that using this as a negative is probably not safe. Let's do yeah. So that negative infinity was because we had a distance of 0 in one of the cases. And we can just probably ignore that, so we don't have to worry about that too much. It'll still be lower than everything else, so that's good. So let's say if... so this means that we might have to recalculate stars based on how I set this up. I'm going to actually set this to a much lower value, like negative math f dot infinity. Let's see if that allows that. And then if it's greater than or equal to negative infinity. So we'll still have this problem on the one outlying case of the sun, which means that I kind of want to skip the sun. So what I'm going to do is just do a quick if check. If which one is the distance? There it is. If foo is equals 0.0f, then what we're going to do is we'll just continue. Actually, let's do it so that we don't have to recalculate it twice. So let's just go ahead and put this one up here. And if absolute, oh wait, not absolute magnitude. That's not the one I wanted. If distance, so we want distance here. Boop. If distance, then we continue. All right, cool. And then we don't need to have distance again here. Doesn't matter what order we put these things in because it's just data. We're just putting it in slots. All right, so hopefully this will still work. Let's just see if it still runs. We definitely have lower values here, right? So what we're going to do now is we're going to set star list. We're going to do star list 0, and we definitely wanted these reversed. So Y and X. So this will give us highest relative magnitude to lowest. And the reason we want this is now we can cull stars based on relative magnitude. So what we're going to do is public game object star prefab. So let's do a public float, actually public int number of stars to generate. Let's default this to 1000 for right now. And so this is our parse data. And let's go ahead and create another function called generate stars. So void generate stars. All right. So generate stars. What we're going to do is for I equals int I equals 0. I is less than number of stars to generate. I plus plus. So we're going to instantiate star list I. Wait, no, this is later. We want to do star prefab. We want to place it in the world at star list I dot position, and the rotation we're going to have pointing towards our camera. So what I'm going to make the rotation is going to be quaternion dot look rotation, and it will be the one pointing to the camera would be the camera last. So transform dot starlist I dot position times minus camera dot main dot actually wait, we just want it looking towards the camera, right? So we can actually just do a quick negative here. We don't have to. We can just do negative starlist dot position. The reason we can do this is this is the direction out from 0, effectively, no matter what. So if we just look back in, theoretically, it should be looking back in the direction that we want. I could have this wrong, but we can always fix this later if it's totally wrong. And we're gonna want an instance of this. So game object instance equals instantiate as game object, and then what we're gonna do is instance dot add component. Oh wait, we already have the component on the prefab, don't we? Yeah, we already have the component on the prefab. So we're just going to fill out instance dot get component star data mono behavior. Dot data equals star list I. That should be it. That should generate all the stars that we want to generate, and they should be generated in relative magnitude order. So let's hit save. Let's hit play and see what we get. There we go. Variable star prefab, star data. Okay, we didn't assign a prefab, so let's assign a prefab. We're going to go to Star Manager. We're going to put our star prefab in here, and we're going to hit play. Here we go. Now it's doing something. All right, it just generated some stuff. So we've got a bunch of star clones. If we go to our scene and look around, we have stars. And they're pointed exactly the opposite direction that we want them pointed. So all I'm going to... Wait, they're pointed real wrong, aren't they? Oh, wait, they assumed that... I assumed that they were around 0. So let's put the camera in 0, 0. real quick. Now they're going to be really close because we're just treating parsecs. These generally represent meters, right? They're now representing as parsecs are much bigger than meters, but we just want to see if this works. So let's go ahead and, first of all, let's make the clear value to black. Second of all, let's make it so that these stars are not transparent diffuse. We want them to be transparent, actually unlit transparent is what we want. There we go. And actually, it might even be better to make them additive, but let's just do this for now. And then hit play. And we can't see any of them because they're all facing out. But you can see that they would be facing the right way if we didn't do that negative. And the reason that is because our quads are what I would consider backwards. They like if you hit play here and you go to one of these and you click on it, you'll see that yes, it's totally facing, like the Z is facing the camera, but for whatever reason, the side that they decided to make the renderable side is the opposite side. So all we're going to do is just remove this negative, and it should just work. Save. Play. So we have some stars. And now the problem is these don't have magnitudes properly. So these just have distances. So this is not going to represent our night sky very well at all. So we actually want to do that somehow. So let's do, let's create another variable here. So let's do public int, or public float. I'm going to call it a ratio. It probably is not the right word for it. I'm just going to say, magnitude to scale ratio 1.0f. We'll just default to 1.0 f first, and so what we're going to do is we're going to give these things a magnitude scale. So instance.transform.scale, we're going to call it local scale, and times equals magnitude to scale ratio times magnitude. So that would be starlist I dot magnitude. And we want the absolute magnitude in this case. So if we save this and hit play, there we go. We've got some really, really big stars out there. It's kind of fun how this is generated. So wow, we have some bright stars in our local systems. I did absolute magnitude, right? Okay, cool. Didn't know we had so many bright neighbors. But let's make this ratio a lot smaller. So let's just go to Star Manager here and make the ratio 0.15 and hit play. All right. So let's make it even smaller. Let's make it 0.5 or something. There's probably a proper ratio that I should use that represents the attenuation fall off for visibility, but I don't have. I'm not going to bother to look that up right now. I'm just going to make it so that it kind of looks right and see if we have something that kind of looks right. So also I'm going to give us a little. Wow, that made them really small, didn't it? Did it make some of them invisible? Alright, whatever. Also, it looks like those guys are angled wrong. Let's actually give a little mouse look to this real quick to find out. Let's go to import package, character controllers, because this has a good little mouse look script in it. Import. And so what we're going to do is we're going to go character controllers, sources, scripts, mouse look, throw this on the main camera, make it so that we have 90 degrees of freedom vertical and 360 horizontal, and we should be able to like look in any direction then. Cool. And yeah, they just look angled wrong when they're at the edges. That's just from the standard distortion stuff. So we have something that kind of sort of looks like stars. It's not perfect because we don't have the magnitude set up exactly right. And also this is only 1,000 stars. So let's see how many we can get away with. Let's do 10,000. Let's see how lucky we can get. So hit play. There we go. 10,000 stars. And it's not too shabby on the rendering either. This is cool. We actually got something working. I am going to make them additive because I think that'll look a lot better. Let me just do that real quick. We're going to go to our star thing. We're going to change them to particles additive. This will mean is if they overlap, you'll get some, yeah, you'll get some overlappy things. Cool. So I don't see, is that Orion's belt? Okay, well, let's add a feature here to do something really cool. Actually, let's see what the comments are first. So, mind prefab. You have line number saying inside the function. Did you use Unity at Sony? I did not use Unity at Sony. Well, while I was at Sony, I started using Unity, but it wasn't because of Sony or because we were using it internally. We actually, when I was there, we were using internal tools. They were all built. They were all engines. And actually, is this true? Yes, it's true. Every engine on every game that I worked on there was internally maintained and created by the Sony Bend team. There were some tools that we used later that were built by the tools and tech people in Sony corporate, but we also maintained those tools locally for our own purposes. Those were level editors and stuff like that. But yeah, everything else was completely internally developed, and it was actually really cool to be working on that stuff. That's the reason I got to do tool chain testing because that's really tough. Actually, it's if your tool chain breaks, it sucks. You know how sometimes you'll get an update to a program and things don't go well? That happens like every other day in game development when you're making your own engine. And so like you have to have a production and development branch, and you basically have to have a team that filters what comes through the development branch to the production team so that you never have a day where they can't work. So this is actually set in relation to the sun. Good question. All this data is, so specifically, it is stellar positions relative to the sun, relative to Epoch 2000, which is roughly the year 2000 at 0 hours, 0 minutes, 0 seconds, where all the stars were at that point. So that's what this is in relation to. When it comes to interstellar distances, the difference between the distance from the sun and the distance from the Earth is negligible. One astronomical unit means nothing in stellar distances. It's nothing. It's like a fingernail thickness is what it is. So it's less than that actually. So yes, all this is effectively set in relation to Earth. So let's add a feature so that we can actually point out stars and see what their names are. So I'm just going to quickly create a C# script. We're going to call this what are we going to call this? Raycast star info box. No, star info raycast. And yeah, that'll be fine. And what we're going to do here is Update. We're going to keep this really simple to start. If physics.raycast transform position, transform, I don't know why it's not giving me the lowercase version, position, transform forward, and layer mask. I want the hit info. We definitely want that. So origin direction hit info. We can just do that. So raycast hit out hit. So if we raycast and we hit something, if hit dot get component. Actually, let's do star data mono behavior equals hit dot get dot transform dot get component star data mono behavior here star info star data. Actually, let's just say star. If star does not equal null, so in case we hit something that doesn't have a star on it, if star does not equal null, then what we're going to do is I'm just going to set a variable here. We're going to call it public string star name. So star does not equal null. Star name equals star dot name, and then what we're going to do is void on GUI layout dot field text field, and then we just give it the text of star name, and then else star name equals blank quotes, and else star name equals blank quotes. There we go. And actually we can just call this private. We don't need that to be public. So let's hit save, throw this onto our camera, and in theory, oh yeah, we need to make sure this has a collider on it, which it actually does, but I don't want it to have a mesh collider. I want it to have just do a sphere collider. Physics, sphere collider. And so if we pull one of our stars out, I just want to make sure that the collider is somewhat similar to the way the star looks. We can actually make the collider smaller. 0.3, yeah. And hit apply, and delete our thing. So now if we hit play, oh, whoops, this gave us the wrong thing. Star clone, that's giving definitely the wrong thing. So, star.name. So, oh, wait, yeah, that's right. That's not what it's called. Data.name. That's what we want. Save. So let's try that again. Hit play. Now we look at something, we get the names. Yay. So what did I think was Orion's belt? That looked Orion's belt-ish. Alright, we're going to need something to show what I'm pointing at. So I'm just going to quickly create a UI. We're just going to create a UI image. We're going to put it directly in the center. So if we go here, does it default to the center? No, it does not. So let's do position 0 and 0. And then let's make this thing use a material of star, actually. Why can't I use this star material? Is that it? There we go. And let's make this red. And so if we hit play now, I don't know why it... Oh, source image. Has to be a sprite. That's silly. Does raw image work differently? UI, raw image. Texture, perfect. That's what we want. We'll delete this one. We'll throw our thingy in here, and then the texture will be default particle. There we go. And then we make the thing red, and we will put it into 0, 0, and we will make it considerably smaller. 1 by 1. Let's see how that looks. Way too small. All right. So 10 by 10. Does that show up at all? Play. There we go. So now we've got a little pointer thing. So is this part of Orion here? I actually don't know what Orion's belt names are, actually. I thought they had fancy names, though. So I'm almost certain that's not Orion's belt, even though I keep thinking that it is. Remember, I've got the sizes kind of wonky right now, so... Honestly, we might be better off just not using distances at all and just using a relative magnitude if we wanted to make sure that this looked like the night sky. Which we could do. Let's go ahead and save this out right now. Save scene, save project. Let's check it in. Hey, all this stuff. The constellation... Okay, so... The star data I'm using is partially data from a database that's sorted by magnitude with certain magnitudes cut off, and then it's also partially from a database of habitable worlds that might be well outside of the magnitudes that we'd expect to see in the night sky unaided by telescope. And so if we sort by relative magnitude, which is what we are doing, we should theoretically get the stars that are brightest to us. But the problem is the way I'm doing the sizing right now is based on both distance and magnitude, and the magnitude to distance ratio is probably very, very, very small. So it might be one of these things where it won't look right to do it that way. Now, what I'm going to try next is to see if we can get the night sky, or at least some close approximation of it. We're going to change it so that instead of actually distancing the stars, we're going to set the stars to a specific distance from us, and then we're going to size them only based on their relative magnitude, and that should approximate the night sky. Thank you very much for the star names. Perfect. So we'll know if we hit Orion's belt. So color temperatures would be cool as well. Ironically, the list that I've got... Okay, the list I've got does have the information, but it has it in the hardest to parse format, which is spectral class. It's a very useful format, but like this, I'm not ready to parse it for this. There's no way. A few of the databases actually have the just strict BV temperature, so that would be easier to work with for getting colors in there. I'm not going to be doing colors tonight, though. I'm not going to deal with that. That being said, I've got more done in an hour than I thought I was going to, so that's cool. Actually, let's just keep this open. We keep coming back to it. So let's try that now. So this is test 1. Is star data a parser that actually does this, isn't it? Yeah. All right, so let's change this so that it works relatively here rather than absolutely. So what we're going to do is, instead of using absolute magnitude, we're going to use relative magnitude. And then we're not going to set the position here. We're going to actually do dot position dot normalized times how far away do we want to put these? Let's put them 100 units out. What's the farthest we can see with our camera? 1,000 units. Let's put them 500 units out. So now they will all be the same distance away. They will just have different sizes based on their relative magnitude. Let's see how this looks. All right, so now I think we need to make this this value that we had really small before much larger. Let's make the magnitude scale ratio 1 and see how that looks. There we go. These are awfully densely packed. Let's make their distances a little bit longer. Let's just make it 900 units. Save, play. Alright, so we've got some stars. I am going to make those hitboxes considerably larger. I don't know what I was thinking, making the hitbox smaller than the visible, when I should be probably making it larger than the visible. Let's make them 1.0F. This means that they might overlap in certain cases, but at least we'll have a little bit more radius to hit. Alright. But MIP levels are not our friends right now. Because you can see the stars get like noticeably darker when we look directly at them because their MIP levels are changing. So our view conic is what, 45 degrees? What is it that we're looking at? How much of the sky at the time? 60 degrees field of view. And that's the vertical field of view. So we actually have quite a bit more than that on the sides. Do we see any constellations anywhere? There's also the problem of I'm not sure how many constellations are defined by the brightest stars in the sky. I would imagine that they mostly are, just because typically constellations are defined by bright points, correct? But yeah, so I'm not 100% certain how visually obvious it's going to be when we actually run into them. Southern Cross easy? No. I was hoping it was going to be more obvious, so you'd be like, haha, we can prove that our data is correct because it looks right. But this is not as easy as I would have expected. Let's also increase the number of stars. Let's try increasing instead of decrease. Actually, let's just decrease. Let's go to 1,000 and see how it looks. All right, here we go. I want to turn off MIP mapping so bad, but I also don't want to make a texture to do it. I guess we can just change the distance again. Let's just do that. Let's make the distance 500 again. Save, play. We might have to change the magnitude to scale ratio to tweak that. Okay, good. Now we're not getting that darkness when we run through them, so that's good. Yeah, this looks like such an empty sky when you only go to the top 1,000. I'm pretty sure that we're destroying portions of our constellations by doing that few stars. But then if we have too many stars, we're having too many stars to actually parse, so let's do visually parse, not... Evidently it's not too much to ask a computer to parse this stuff. Actually, what's amazing is I'm using my internal card right now and I'm still broadcasting, so this is on a integrated graphics card right now, And I'm not going to risk turning that to something else. Okay. Turn you off. Yeah. I'm not sure of a good way to tell if our data is properly projected. Maybe I'll get some constellation data, find out where I need to aim, and then we'll aim at it and see if it looks like a constellation at that point. Or maybe I'll just parse down information to just 3 constellations and see if if they show up and not reversed and in the proper locations, etc., etc. That being said, I think this is actually working right. Certainly looks like stars. I mean, that being said, I could randomly create points and it would probably look pretty good. As a matter of fact, we could do that if we wanted to test how a random distribution looks. This does look like something, though. Like, you can see that there's bands and there's areas and there's kind of a... Let's actually compare it to random data. I'm curious. I'm going to do it. I'm going to compare it to random data. I'm going to first just call this... I'm going to change the name of this... Well, I'm not going to change the name of it, but I'm going to check it in as save scene, save project. Stars based purely on relative magnitude. The relative magnitude is our view of it from the Earth, what the actual magnitude of the star would be. Which also may be why, again, I might have actually done the calculation wrong. Like in our star data thing, don't save star data. We might be doing this calculation wrong for all I know. Either because our source information was wrong, which is probably not the case, or because I'm making an assumption or something that isn't valid. So it's possible that there's a lot of places that can be broken. But for right now, let's try a random case just to see how it looks. And I'm just going to wedge it in here. So what we're going to do is, so what are we using? We're using the position, and we're using the relative magnitude. Those are the 2 things that we're using. So what we want to do is... we'll just do position is going to be very similar. We're just going to make it random. Sometimes it's fun to do this just to see how not random looks. So we're going to do random dot... Well, since we're only using the magnitude, since we're only using it in a certain way anyway, we could probably get away with just random.value in this case. Let's just do it. Let's just see what happens. Random.value, random.value, and random.value. And then the absolute magnitude, what is our range for that? Oh, wait, we're doing relative magnitude, so I have no idea what our range is. So let's just do random between 0 and 100. Random dot value time. Yeah, let's do random dot range 0.0f 100.0f. This is probably going to produce much larger stars than what we have been seeing before. But let's see what it does. Play. Okay, well. Oh, yeah. Might help to have some negative values in there. So right now we're doing just positive values. So let's do random.value. Yeah, let's just do random.range -1.0f and 1.0f. And let's make these sizes much smaller. Let's do between 0 and 10. Save. Play. Alright, this is just random data. Well, not entirely. This is random data. Like, these positions are not right. This is just random. But we also attached names to them for no reason that don't have anything to do with their position. And actually it does look still very star-like, so I guess we have much better random than we used to have in the day. You can see that kind of there's columns in groupings at certain places, whereas the original star data, which was here, I guess, and it'll be different each time too, so it's kind of hard to tell. But absolute magnitude equals what was the? Oh shoot, I don't remember which value this was. Let's just undo things until it goes back to what we want. There we go. Let's do this again. There's more of a horizontal bias on this stuff. Which I think makes sense just because of how the universe tends to be. I mean, that's not true, but our galaxy has an angle to it, and we're kind of in the same angle, I think. I don't know. I don't know anything about astronomy. I don't know what I'm talking about. This is not entirely true. I actually enjoy astronomy quite a bit, but I'm not like an expert on it by any stretch of the imagination. But I love data, and I love visualization. I think this is right, but if it's not, we'll fix it. I'm going to fix it some other time. I'm really happy with how this turned out. I'm just going to go ahead and save this, save project, make sure that we're all checked in, we're good. Maybe I should have two different versions. Let's do that real quick, just so that if people have access to the Cooking with You repo, super depot, super repo, whatever it's called, the Cooking with Unity super repo, you can just download this stuff. Let's reorganize it first. Let's go create folder. We're going to do script, create folder, data. We're going to put the data here, and we're going to put have HYG there. We're going to put scripts. We're going to throw all these in here. We're going to create a folder for prefabs. Might as well prefabs, just so it looks professional. And then create another folder called materials. And since even though we only had one material in prefab, might as well have a scenes folder as well. Scenes. Alright, so now what I want to do is let's just check this in. Save scene, save project. Remember, to get access to the Cooking with Unity super repo, all you have to do is pledge $1 or more on Patreon, patreon.com/cookingwithunity, and then you get access. Just send me an email, and after you sign up with your GitHub username, and I'll give you access. Reorganization, commit. And then let's. So remember, we had a version before where we actually put the distances in properly. So let's do that. So this one we're going to call. I'm going to rename this scene to relative magnitude only. And then we're going to. I'm just going to duplicate this, and we're going to call this one. Position and absolute magnitude. So this one, so we actually changed script data here, so we're going to have to create a boolean or something, so I'm going to do that. We're going to go to our star data parser. I'm going to call it just public float, public bool, relative magnitude only equals, let's call it true for now. And so relative magnitude only we're going to do here. So if relative magnitude only, then we do it this way. And then the old way of doing it, I think we can just copy and paste it from where we had it in our check-in here. So star data parser, here we go. So we're just going to go grab this version, copy that and paste it else. And then we still get the star list. And then we apply the scale to be based on absolute magnitude. So save. So now if we go to our star manager, we're going to turn this off for this one, and we're going to change the ratio back to 0.5, 0.05, I think is what we used. That was actually pretty decent. And hit play and see how it looks. There we go. So this one's off by a bit because we need a proper ratio, and the ratio may be non-linear, is highly likely to be non-linear. Let's put it that way. So so this will require some more work to be right. The other one's more likely to look like the night sky as it is. So save scene, save project, but I'm going to put both in here just in case people are curious or want to play with it on their own. So let's make sure that the other scene still works the same as it did before. So relative magnitude only, we go here, hit play, and this should look like yeah, there we go. Cool. Good enough for me. I'm going to quit this, and I'm going to call that a wrap. Though I'm going to call it a wrap after we check the comments real quick. Commit message, splitting out both versions of the star generation. So let's see what we got. Are they already escaped? Define escaped. On parsing CSVs, how do you escape a string that contains a comma? Well, these would... So I think that the person who made these doesn't use commas anywhere. The typical way that that's handled is... so I'm going to show you right here. This is a really good question, actually. So typically when you're dealing with CSVs, if you use comma as your separator, you are not supposed to put commas in your data. However, you can. And the way you do this is you encapsulate the data in quotes. And so when you're parsing something that actually does... Here, let's find quote. Let's see if there's a quote anywhere in here. So there's no quotes in here, which means that there should not be any encapsulated commas. If we did find quotes, then it would mean that we would have to actually check for that case. So we couldn't split on the comma alone. We would have to make sure that the comma is not within two quotes and cancel those ones out. It's a little bit more of a pain in the butt. Luckily, this data doesn't use commas, so we don't have to worry about it at all. But yeah, so that's how the escaping works. Can you throw a short statement to highlight one of the stars Vlad suggested so we can pinpoint the stars and then see if the surrounding stars looks like Orion? That's a good idea. It's a really good idea. Yeah, let's see if this is in the data first of all. So if we go to HYZG and we find Alton attack. Probably should have done this in the text editor because it's really acting like this is hard. I'm going to go ahead and do it in text edit while we wait for that to do something. What are we opening? We're going to open HYG. We're going to go with, what is it called? Open with text edit, and we're going to find, there it is, Altenac. Alright, perfect, so that one's definitely in there. My Patreon link, as described, is patreon.com/cookingwithunity. You can also find a link to it in the burger. It says support the show, and that's the Patreon link. So Altenac's in there, so that's probably good enough for me. And does it actually just have Altenac? Nothing special. That's it. All right, so let's do it. So let's quickly throw that together and highlight those for the fun of it. So let's go into star data parser. So we'll just change the material so that they're a different color. Let's turn them green. So if star list I dot name equals Altenac. So if it equals Altenac or so we'll just do and so what I'm going to do is we're going to make it so that the color is different. So instance.transform, instance.renderer dot material.color equals color dot what'll show up best. Let's go with cyan. Save. And let's, for just right now, let's make them gigantic too. Instance.transform.level scale times equals 100.0f. Let's just see if these should become really obvious then. We're definitely going to make it less obvious in a second here, once we actually want to see if the constellation is there. So if we go around here, so I'm not seeing any ridiculously large ones, which probably means that we do not have enough stars in our data here. So if I increase the star count to 10,000, there we go. All right, let's just do one additional thing here too. Let's add some debug logs to see if we actually get here. Debug.log starlist I.name. So save, play. Do we get any debug logs? Not looking like it, though it might just be. Yep, we didn't. All right, let's make our range bigger. Let's just do it. Let's just go all out. This is going to crush my computer, especially in integrated graphics mode. Argument out of range exception. Argument out of range. Index. Oh, we did more stars than we needed there's in the database, so. Huh, the fact that it didn't come up with anything is kind of scary. Let's go 40,000. That looks really cool. I can't believe how well this runs, actually. I can probably make it run better, too. No, I can't. Okay, never mind. So that's kind of disheartening. Macs are better than PCs for game development. I hate these type of discussions. They're my choice for game development right now. That's not to say that they're better. As a matter of fact, if you like Visual Studio, I highly recommend that you use Windows for development and get a Visual Studio plugin for Unity, because because Visual Studio is really nice. Certainly a lot nicer than MonoDevelop. Definitely has better autocorrect and autocomplete stuff. It's just really cool stuff. And if you're used to it, especially, definitely, it's nice. Even if I was developing on PC, I would on my show I'd still be using MonoDevelop probably, because I want the experience to be relatively the same for people who are using Mac or using PC. Because the honest truth is, it doesn't matter. Computers are computers are computers. It mattered a little bit more back in the day when computers had different architectures and stuff, but nowadays a Mac has an Intel standard x86 architecture or x64 architecture, same as any Windows machine. So I mean, it's really a matter of preference, I think. And in my case, right now, I hate Mac OS slightly less than I hate Windows, and so I use Mac OS. I do not like the new version of Mac OS. Like, I'm not a big fan. I hate the new visual look of the new operating system. I'm not using it. You can see my buttons are still round. So it's a free upgrade, and I have not done it because... And I tried it on another computer first, and I'm just like, yep, this is not happening. I haven't upgraded my iOS stuff since iOS version 6 either, for the same reasons. I think that they have made some serious mistakes in the UI. And so I might be getting a non-iOS device in the future, and I might be getting a non-Mac device in the future, just depending on how things go. I'm hoping that Windows 10 or 9 or whatever it's called ends up being awesome, because I like operating systems to be awesome. I'm not someone who wants one side or other to win. I want both sides to be brutally murdering each other with innovations and doing a really great job. And I feel that both sides have actually been lacking in that department lately. So... Space and this messing the string compare. It's entirely possible, except for when we looked at it in the text edit, it looks like these don't have any extra spaces or anything. So let's just do a quick star last name equals all Nitak, all Nilam, and Mintaka. So these are ors, that's right. What's the best way I could do this? We could dump this to... We could just dump all the names to disk or something. The fact that it's just not finding it is weird, but it probably is something wrong with our parsing somewhere. I did save this, right? Yeah. Okay. Starlist.name is right? Yeah. Because this is based on star data and stardata.name, which is what we want, yes. Let's try something. Let's do this. Now that I found that we can actually handle putting all the stars visible at the same time anyway, even on integrated graphics, which actually is just still blowing my mind. Let's sort them by their name, considering both of these start with A's, which is super useful. And let's compare x dot name compared to y dot name. So we hit save on this, and then we make the star size much smaller. Star Manager, let's just do 1000. Let's just see, actually let's just do 100. I don't think that's going to be enough, but let's try it. Hit play. I just want to be able to actually go through our star list here. Oh wait, yeah, our star list is still... Oh, there's ones that start with 1. That's useful. Yeah, this is going to be impossible to sort through still. Here, let's look at it in this numbers thing here. Let's just sort by, we're using the display name, right? So let's sort ascending. Wait for a few minutes while my computer crunches on that data. And see what anyone is saying while that's crunching. Yes, I've used Linux. I use Amazon Linux all the time. I've used Ubuntu, I've used Red Hat, and I used Fedora at one point a long time ago. And yeah, so Linux isn't an option for me because I like Unity, and Unity isn't available as an editor on Linux, so that's already a big problem. But and I hate dissing people's operating systems. If it's a good operating system for you, that's great. I'm glad that you like it. But I'm a GUI guy. I use a lot of command line too. I mean, I've got a button. I can hit F1 and it brings up a command line interface. So the thing is, I use it a lot, but and for command line, Linux and Unix style systems are awesome. Like, their command line is just beautiful. It's part of the reason I really like Mac OS, is because you don't have to use Windows PowerShell or whatever nonsense they have. Shell scripting is super easy in Bash. It's nice. You can just do things at the command line. But graphical user interfaces for Linux are the most inconsistent junk I've ever used. And that's the main reason that I've avoided them as a personal personal choice for operating system. You definitely cannot beat the price. Linux is free, which is awesome. There's a lot of versions of it. You can find something that's very specific to you. If you want to develop for it or change it, you can do that. It's possible. It's everything is open source. So there's a lot of things that are nice about Linux. But I think it kind of falls into that category of you get what you pay for. I think that the user experience as a computer user, and not necessarily a database administrator or a server manager or something, it's not a very good user experience. It's a great user experience for when you're in the command line, not so great in the GUI. So that's how I feel about Linux. In my case, I would probably not choose Linux just because of the Unity problem. Because I really love Unity. So this is now sorted in some alphabetical order. Let's see what these look like. Alpha. Alright, we just got past the. Maybe there's a number or something. I didn't see it in there. I swear that it just was what we wanted, though. Here, let me look again. That's the wrong thing. Oops. That was exactly what we wanted. Yeah, it looks like it's just Alnitak. Oh, okay. Evidently they went with 50 Zeta Orionsis. This is actually not the display name, I don't think. Let me undo that sort. Alright, let's just see if it contains it. Let's just try that. If name dot contains Alnitak. I don't think this is going to fix it, actually, but let's try it. Because I think what's happening is the display name is not one of these names. It's a different name for some reason. Dot contains. Save. See how this works. Hit play. Oh, now we definitely want more stars, though. So let's go back to our star manager, switch this over to number of stars to generate 40,000, hit play, see if we get any debug logs this time. Alright, I'll also I want to switch this back before we forget. Save. All right. So it still didn't work. So I think it's using something else. Let's go to text edit and let's look at this. So it would be 30. Let's do 38022. 38022. Let's just look at it. Zero, 2, 2. I'll attack. And we're using, this is the third thing, we're using that for the name. So value's 3. It doesn't have like an additional space or anything. So we definitely should have found all in attack. And yeah, we're getting no debug.logs. Oh, wait. Relative magnitude only is what we're using. That's our problem. I am an idiot. Classic mistake. This is the one that we're actually using. Well, there you go. Let's see what happens if we hit play now. We should get 3 debug.logs. It'll be great. No, we didn't get any. I did save, right? Okay. Well, dang it. There goes that. Alright. Well, dang it. I thought that was totally going to work. Because we're using relative magnitude only on this one, right? Yeah, we are. Go to Star Manager, we look at it, it says relative magnitude only. So we're in here. Let's try not to do the contains, let's just do the equals again. Let's see if that fixes anything. Play. Come on, I just want 3 debug logs. That's all I'm asking for. Alright. How many stars exactly do we have in this thing? Just in case. Just in case there's... Alright, so it looks like we have 45098. Let's just use the whole thing. Actually, let's not even use the number of stars to generate. Let's just ignore that. I is less than... starlist.length.count. Save. Let's try that. Oh, we got some debugs. We got 2 of them, Alnitak and Alnilam. Somehow we still didn't get Mintaka. But at least we got them. Okay, so we're going to look over here. This is... Are both of them there? It looks like it is. Let's just pause the game here. And let's find these. They didn't really change color. That's unfortunate. Oh, that's probably because it needs tint color to be changed, doesn't it? Let's actually do that real quick, so that we don't have to scale them so much. So what we want the color to be is, we actually want to do material.set color _tint because we're using a shader that uses tint rather than color, and then we set it to color cyan. Save, play, see if they actually become a different color. No, they still didn't become a different color. Sweet. Why is that? So if we go to Material, Star, Inspector, Tint Color. Maybe it's called Tint Color. File, save. Let's try this one more time. Save, play. There we go. Different color, yay. So let's now make them their normal size. So we're just going to go to, let's just not scale them up and see how it looks. Now that we kind of know where to look. Should show up. Color should be pretty obvious when we're looking around. Assuming they're not so small that we can't see anything. Well, maybe it's not so obvious. Alright. So, wait, it wasn't working before when we were looking at like 48,000 stars? Is that really something that happened? Not crazy in that, right? Stars to generate. Let's look at this again. If we use this again, hit save, go to Star Manager and set this to 45,000. We got nothing. Considering they're showing up like in the very last, leads me to believe that we're calculating our relative magnitude wrong, which is probably true. I said that earlier, that it very well might be wrong. Quickly do something here. Public bool generate all stars equals false, and then what we're going to do is if generate all stars, number of stars to generate equals list star list dot count. So now we can just actually have it generate all the stars if we want to without having to change code every time. So if I set this to just like 1 star, this will generate 1 star, and it'll be very lonely, and it will generate what is evidently the brightest star, which is NN3829b. I've never heard of it, so that makes me extremely skeptical of my calculation for relative brightness. But so generate all stars, and it generates all the stars. Cool. So let's make these things big again, but not as big. Let's make them times 10f. Hit save, play. There they are. So if I were to zoom in on this, so I'm going to pause the game, Command Shift P, and then we're going to go into the game view, and I'm going to find, where is our main camera? There we go. Let's make the field of view smaller. Alright, let's See, I can't rely on generating less stars because you saw that I had to bring it up to like 46,000 before these stars even generated. Does anyone see Orion in there somewhere? Is that the third star there? Let's see if we unpause this. Oh, no. Where did I go? There it is. Alright, so is this actually... No. BD... Yeah. Yeah, I don't know. Feels wrong to me. But they are close together at the very least. So that's a good sign that they're close together, right? Because they're supposed to be really close together. But I do think there's some problems. But I think this is a good stopping point. So I'm going to just save scene, save project. And quit out for reals this time. See, this is what happens if I don't have a set time limit. I just keep going forever, so it's no good. All stars option push. All right. Star data does not, but star data mono behavior does. Yeah, display name is actually better than proper name in most cases because it gives you a name. Proper name is when they have proper names. Display names is the best name that this guy decided to pick out of his on his lonely self when he was making this database. All the names of this particular star, the one I found personally the most aesthetically pleasing. So that doesn't necessarily mean that it will be the name that we expect. So, versus proper name where you might not get a name at all. In the case of Alnitak and the other one, those both had the same names for their proper name and the other one. But evidently, what's the other one? Mintaka did not, or wasn't on the list for some reason. So, let's see what we got here. Are we on relative magnitude? We are. Brightest star should be Sirius. Okay, good to know. Is that actually brightest as in, like, relative, or brightest as in just brightest? Most of my astronomy I learned from the game Free Space, so that's a lie. But, okay, this is just taking forever. I'm not waiting for it. Okay, I'm done with this episode. Cool show, very educational. Yay! I'm glad that you guys liked it. So thank you for watching. And if you have any questions, please email me at pushypixels@pushypixels.com. If you want the code for this episode, it's available in GitHub under the Cooking with Unity super repo, which you can get access to if you donate to the show. $1 a month, and you get access to it for as long as you're donating. So it's only $1. This is the cheapest subscription that you will have. Well, maybe not. I don't know. There might be something cheaper out there, but it's probably not many things. So, you guys have a good one, and I'll see you tomorrow for Breakfast with Unity at 8 a.m. PDT, and then also at 8:30 p.m. PDT, we'll be doing some, what's the project we're doing? Light gun. We'll be working on our light gun game. So thank you very much, and you guys have a great night. Alright, so this is banter time, but I kind of already did the comments thing because it was kind of useful to actually do the comments thing. Yeah. Look around you. That's a great suggestion. I love that. I'm still really impressed with the rendering performance of Unity. I didn't expect things to go as well as they did with the size of the data that we were working with. Obviously, if we tried to turn that into more dynamic data, it would probably be really bad. Like if we had like each star had a script on it that had an update, I'm sure that would just destroy things. I don't care. We'll just delete this. This is not something we need. It's just based on the CFV that we kind of do need. All right. Yep, that's enough. Stop the streaming. I'm sure we've been doing this for more than an hour. And we have. Hopefully this will still be viewable afterwards. I've heard... I forgot about that. Hopefully... Oh, please let this be viewable afterwards. Please, please, please.